Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad AZHARUDDIN bin ANGSOR. My matric number DE190192. So I'm from group 9 and I will explain about my assignment, which is the topic that I choose is deflection bookshelf. So for the objective, our objective is to build bookshelf able to carry book with height of 9 to 14 centimeter and length about 30 centimeter. Second is to ensure that the bookshelf is height durable. Third is to find the root of equation by effective method. And lastly is to list in filler table. So the method that I used to solve this problem is bisection method. So move to problem statement. So one is student today are carrying heavy backpack filled with books. Second is many bookshelf that have robot is less durable. This may be the calculation may be wrong. So next is filler table. So I have I have 6 points that I have that contain in my filler table. So first is fact, second is idea, third is learning issue, and fourth is action. So for the fact, number one is the problem statement was created in order to understand the application of numerical method in engineering. For the idea is to decide to make a study about student problem with carrying heavy books. For learning issue is by design a strong bookshelf that can reduce the student's burden of carrying heavy backpack. And for the action is to find information through researcher article and books. So for second point is to finding the solution that can be related with numerical method for the problem. So for the idea is to understand the term used in the problem. For learning issue is what is the method that can be related with the problem. And for action is to analyze the problem statement based on the condition given. So for fact number 3 is numerical methods are widely used in engineering. So the idea is to list all the numerical methods that learn in syllabus that can give idea to the method that can be applied. So for the learning issues is what is the suitable method for solving the problem. And for the action is to discuss to discuss with all the group member and all agree to choose bisection method. So for the fact number 4, choose to design a bookshelf as solution. For the idea is design the suitable bookshelf. For learning issue is does the shelf are suitable use for a long time. And for action is search information through books and website that can related with the problem. So for the fifth is bisection method were used in design a structure. For the idea is to design a long-term use which is to reduce the bookshelf from sagging. For the learning issue is how to solve the problem given. And the action is understand the problem and make a literature study about the problem. So for the last one is for the fact number 6 is analyze the maximum deflection of the bookshelf. For the idea is to ensure for high durability bookshelf for long use term. And for the learning issue is what is the point of maximum deflection? And the action is using bisection method to find point of maximum deflection. So this is my conclusion for part 1 and part 2. So part 3 will continue by Nabil. So yeah, that's all for me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Nabil. My metric number is DE170072. And for this assignment on this project, I will explain about the chapter 3 or part 3 of this assignment. So I'm going to explain about the methodology. So basically, in the introduction part to the methodology, the problem statement that has been stated earlier can be solved by using secant method, right? Bisection method. And according to the mathematically problem, the maximum deflection it is would be along between its length L of the bookshelf. And this problem will arise when the weight of load is placed on the bookshelf, and therefore sagging can be seen. This is because the weight of the load that acts on the bookshelf is directly proportional to deflection that will occur. And the figure below will show that the deflection occurred, and the maximum deflection can be determined at where it will take place. And this figure is about a loaded bookshelf. So we are calculating about bookshelf. We start the calculation here. So the solution is the maximum deflection will be between x equal to 0 and x equal to L, where L is the length of bookshelf, and for the first range, 0 less than equal to x and more than equals to L, and 0, and for the second range is 0 less than equal to x and more than equal to 30. And we assume that x1 equal to 0 and xu equals to 30. So check if the function changes sign between x1 and xu. So fx1 equal to fx0. So we calculate the fx1 and we will get the value equal to negative 0.0185007, and fxu f30. So fxu, and we plug in the numbers into the equation, we will get the 0.018684. So fx1 times fxu equals to fx0 fx30 equals to negative 0.018507 times 0.018684 will become less than 0. So there is at least one root between xt and xu. Iteration 1. The estimate of the root is xm equal to x1 plus xu per 2. So we skip this and we will get the value equals to 15. So fxm is fx15 actually. So we plug in the values and we will get the answer is 8.259084 times 10 to the power of negative 4. So the final answer, like the previous one, still less than 0. Hence, the root is bracketed between xm and xu. That is between 15 and 30. So the lower and upper limits of the news bracket are xt equals to 15 and xu equals to 30. And at this point, the absolute relative approximate error cannot be calculated as we do not have the previous approximation. So in iteration 2, the estimate of the root is xm equals to x1 plus xu per 2, and we will plug in the value and will result the number of 22.5. And fxm for this iteration 2, f22.5, we plug in the values and we will get 0.01385. So fxm equals to fx15 and f15 and f22.5. We plug in the value and still we will get less than 0. So hence the root is bracketed between xi and xm, that is between 15 and 22.5. So the lower and upper limit of the news bracket, the new bracket, xl equal to 15 and xu equal to 22.5. So this part will explain about the absolute relative approximate error at the end of iteration 2 is stated as below. 22.5 minus 15 per 22.5 times 100. So we will get 33.333%. none of the significant digits are at least correct in the estimated root. And so exam equals to 22.5, as the absolute relative approximate error is greater than 5%. So we will continue with iteration 3. Basically, they are the same as iteration 1 and 2, except for the numbers and the values. And you can see the result. So here is the tabulated part. Still, none of the significant digits are at least correct in the estimated root of the equation, as the absolute relative approximate error is greater than 5%. So we tabulated the data. We use iteration 1 until 10. Sorry. Xi, exam, xu, the relative error in percent, and fxm. So you can see the data, the tabulated data will be stated as like in the table. And at the end of the 10th iteration, we will get 0.193%. Hence, the number of significant digits at least correct is given by the large value of m, for which the iteration equals to less than 0.5 times 10 power of 2 minus m. So with the calculation involving logarithms, we will get that m equal to 2. So the number of significant digits at least correct in the estimated root 15.030 is 2. So that's all from me.